What is trigonometry about? Just Googling that phrase results in the following. Trigonometry is a branch of mathematics that studies the relationships between the sides and the angles of triangles. But is this really the best description of trigonometry? Some say that trigonometry is best understood with circles instead of triangles. But is that really true? And so in this video, I will be examining both what I call the triangle description of trigonometry and the circle description of trigonometry. And I've come to the conclusion that
Okay, before we can draw any conclusion, we need to first explain what I'm calling the triangle description of trigonometry and the circle description of trigonometry. The triangle description is what most people know. Geometry measuring the ratio between different sides on a right-angled triangle. And they do this by using the three main trigonometric functions, sine, cosine, and tangent, where each of these functions input an angle, say theta, of the triangle, then output the ratio of two sides of the triangle. But which sides exactly? Well, most people remember it by SO katoa, where the S in SO stands for sine, and then the next two letters represents the sides we are outputting the ratio of. In this case, the side opposite of the angle and the hypotenuse. So sine of some angle, theta, outputs the ratio of these two sides. Now, this is an okay way to memorize this, but I go for a slightly different way to memorize it. The cat sat on an orange and hurt horribly. I will let you figure that one out for yourself. Now on to the circle description of trigonometry. If you look at a unit circle, you know, the circle with a radius 1 on a graph, and say you move a distance t around the circle. The x-coordinate here is cosine of t, and the y-coordinate is sine of t. And this, at least for me, seems to be a better way to approximate the values of trig functions in my head. And it also makes more sense to input an angle greater than a right angle. For example, cosine of this angle right here actually makes sense to be a negative number. But then again, there doesn't seem to be any good way to see the tangent function in this circle. Without using the triangle description of trig, that is. See, if we look at this line right here, this forms a bigger triangle, as you can see. And the ratio of this new line and the original hypotenuse is equal to the opposite side divided by the adjacent side, which is by definition the tangent function. And so this new line from the unit circle is equal to tangent of t. And this is why I think the best way to think about the trigonometric functions is circles and triangles at the same time.
And this is actually a very important lesson to learn in mathematics. Many times in mathematics, we come across scenarios where there are multiple different ways to learn something. Take for example complex numbers. Most of us are used to the normal rectangular coordinate system that complex numbers are in, with real numbers on the horizontal axis and complex numbers on the vertical axis. But there's another way to understand complex numbers, and that is using polar coordinates, which at first may seem to be a bit confusing, but it's actually way easier to understand things like Euler's identity for complex numbers using that coordinate system. And so it's actually a good thing to learn about complex numbers, knowing both coordinate systems and getting an intuitive sense for both of them.
Okay, that's all for now. Thanks for watching, and please subscribe if you enjoyed this content.